Okay, so in this video, I'm given, again, two functions, f and g, and I want to find the sum, the difference, the product, and the quotient of these two functions. So my function f is the square root of x plus 1, my function g is 2 over x. I think I'm going to start this time by finding the domain of these two functions, because the domain is going to be a little bit more interesting this time. So to find the domain of f, I know that I have a square root sign. So I know that I can't have a negative underneath my square root sign. And so x plus 1 must be greater than or equal to 0. X plus 1 must be greater than or equal to 0. Solving this inequality, subtracting 1 from both sides, I know that x therefore must be greater than or equal to negative 1. And so my domain for f is hard bracket, just erase that, put in a hard bracket, minus 1 to infinity. Right? This hard bracket tells me that minus 1 is part of the domain. Okay, so that's the domain of f. So now I want the domain of g. So I want the domain of the function g. Well, g is 2 over x, and so I know that I can certainly have negative numbers in the denominator, positive numbers. The only thing I can't have in the denominator is 0. And so the domain of g is all real numbers other than 0. And so we would write that the domain of g is negative infinity to 0, soft bracket, parentheses, union 0 to positive infinity. So my 0 is not included, is what these soft brackets are indicating. My 0 is not included in the domain. Okay, so now that I've established what the actual two domains are, I can now go about solving my problems. F plus g, f minus g, f times g, and f over g. So let me put that right here. Okay, to start, part 1. F plus g. Well, that is square root of x plus 1 plus 2 over x. I might be tempted to just leave it like that, but I will combine them. I will find a common denominator. The common denominator of these two, if I consider the square root of x plus 1 as the square root of x plus 1 over 1, I will have a common denominator of x. And so 1 into x goes x times square root of x plus 1 is simply x times the square root of x plus 1. I have a plus. X into x goes once times 2 is 2. And so that is the sum of my two functions. The domain is the domain of the two functions, the two original functions f and j. So we know that the domain of f is minus 1 through infinity, including minus 1. The domain of g is all real numbers other than 0, and so if I combine those, the domain of f plus g will be minus 1 through infinity other than 0. So minus 1 all the way up to 0, not including 0, and then greater than 0 through infinity. And so I would write that the domain is minus 1 to 0, soft bracket, 0 is not in the domain, union 0 to infinity. And that is the domain of f plus g. All right, subtract these. Part 2, we want f minus g, so that is root x plus 1, root x plus 1 minus 2 over x. Again, to subtract them, I'll find a common denominator of x. 1 into x goes x times. I have x on root x plus 1 minus x into x goes once. 1 times 2 is 2. And that is f minus g. This is part 2, f minus g. The domain is the same as the domain here. The domain is the combination of the two domains from my original two functions. So the domain is the same. It is minus 1 to 0, including minus 1, excuse me, but not including 0, union 0 to infinity. So that's my domain. Okay, part 3. For I want the product, f times g. So that is the square root of x plus 1, the square root of x plus 1 times 2 over x. Okay, to multiply them is just top by top, bottom by bottom. So that will give me 2 on the square root of x plus 1 all over x. And that's the product. The domain, I now have a rational function, and the domain is the same as the domain here. The domain of the product of two functions is the domain of the two original functions combined. And so I have, my domain is, as it was before, minus 1 to 0, union 0 to infinity. That's my domain. So it is all of the numbers from minus 1 to infinity other than 0. All right, last one. I'm just going to erase right here so I have a little more board space. So part 4. Part 4 is f over g. And so f over g of x, which will be the square root of x plus 1 all over 2 over x. I will invert my denominator, bring it up, so this is the same as the square root of x plus 1 times x over 2. Invert my denominator and multiply. And so I get x times the square root of x plus 1 all over 2. The domain here is, again, the domain of the original two functions. However, I have to be careful that to exclude any values of x that would make g of x 0, because I'm dividing by g of x. So I have to make sure I exclude any values of x that would make g of x 0. Well, g of x is 2 over x, and that can never be 0. I have a 2 in my numerator, and therefore 2 over x can never be 0. And so I don't need to worry about it. There are no values of x that would make g of x equal to 0. There are no values of x that make g of x equal to 0. And so my domain is just as it was before. My domain is negative 1 to 0, union 0 to infinity. Okay, and that is my answer. We have performed this operation on these two functions. We have found the domain in each case. Thanks a lot.